This video is on the objective use the sum and difference formula for tangent. And this is number 1, so the first video on a question related to this objective in your Newton Alta homework. Alright, so before I get to the question, hopefully let me write out for you what the sum formula is for tangent and the difference formula. Just to refresh your memory, hopefully you've been seeing this stuff. You've read section 9.2 in your OpenStax algebra and trigonometry text, or you've looked at more instruction in the Newton Alta assignment. Remember the sum formula. All right, so we're doing the sum, S-U-M. Right? The sum and difference formulas for tangent. Alright, so first I'll do the sum formula, and they're very, very similar. Right? Just some changes in signs. So if you remember the tangent, alright, the tangent of the sum of two angles, say angle alpha plus angle beta, or A plus B, whatever you want, but the tangent of a sum of two angles is equivalent to, and then there's a fraction, remember. In the numerator of this tangent formula, the tangent of a sum or the tangent of a difference, is kind of like you're distributing the tangent, even though it's not really what you're doing. Alright, it's not distributing. But the numerator is the tangent of the first angle, tangent of alpha, plus the tangent of that second angle. Right. So again, the numerator is kind of like I'm distributing, but I'm not. All right, there's more to it. There's a denominator. And the denominator is 1 minus. Right? If there's a plus up here, there's going to be a minus down here. And then the product of the tangents of those angles. Right? The tangent of alpha multiplied by the tangent of beta. All right. So there's the tangent of the sum of two angles, written in terms of the tangent of each individual angle. And then the difference formula, the only thing that changes are the signs. Right, the tangent of the difference between two angles, say alpha minus angle beta, is a fraction, written like this. And again, the numerator is almost like I'm distributing, even though I'm not, right? It's not distributing. But the numerator is the tangent of the first angle, alpha, minus the tangent of the second angle, beta. And then the denominator is 1 plus. Right? If there's a minus up here, there's a plus down here. And then the product of the two tangents, right? The tangent of alpha times the tangent of beta. And notice how very, very, very similar these formulas are. Just the signs change, right? The pluses become minuses, the minuses become pluses. Okay. So hopefully you can keep this in mind when we go through the question. Alright, so here's the question. Now again, if you want to see more, click on more instruction, look at their examples, their videos, their notes, and hopefully that helps you out. Alright, so here, we are given that the tangent of some angle called alpha, A, I almost said alpha. The tangent of angle A is 8/5, and the tangent of some other angle called angle B is 7. If this is the case, what would be the tangent of the sum of those two angles? Right? If I were to take angle A's measure and add it to angle B's measure and find the tangent of this new angle, what would be the tangent of that new angle? Alright, so I'll go to a piece of paper again, write out all this information. Right, so we are given that the tangent of an angle called A is, 8/5. And the tangent of another angle called B is 7. And they want us to find the tangent of the sum of these two angles. Right? If I were to take these two angle measures and add them together, and then find the tangent of the new angle. Well, again, using our sum formula, right, we can take the tangent of a sum of two angles using the tangent of the individual angles themselves, the tangent of A and the tangent of B. The numerator, again, is the tangent of the first angle plus the tangent of the second. Right? So tangent A plus tangent B in the numerator divided by 1 minus the product of the tangents. Right? The tangent of A times the tangent of B in the denominator. And they ask us to give our answer as a simple fraction. All right, so tangent of A is 8/5. Right? Plus tangent of B is 7. So that's the numerator, divided by 1 minus, and then 8/5 times 7. Okay. Well, this is a complex fraction, right? Fractions within fractions. So I have, 8/5 plus 7 in the numerator, divided by 1 minus, and then 8/5 times 7 would be 56/5 in the denominator. And I'd like to get rid of these little denominators of 5. So I'm going to multiply all this in the numerator and all this in the denominator by 5, right? So I'm going to multiply by 5 there and 5 there. So we'll distribute the 5 in the numerator, distribute the 5 in the denominator, and that'll get rid of those denominators of 5. All right, so what we have here is, now 5 times 8/5 would just be 8 plus 5 times 7, 35. So the numerator is nice and a lot simpler looking now. Same thing with the denominator. 5 times 1, 5 minus 5 times 56/5 would be just 56. All right, so 8 plus 35, 43 in the numerator. 5 minus 56 be negative 51 in the denominator. Right, so this is negative, right? Positive divided by negative, negative 43/51. And I'm pretty sure that's as simple as that'll get, right? 43 is a prime number. 51 is 3 times 17. These don't have any common factors. So there we go. I'm going to enter it negative 43/51 minus 43 over 51. And submit. Fantastic. And again, they'll take you through the tangent of a sum formula, filling in all this stuff. And they put the fractions up here together, put the fractions down here together, and then multiplied by 5. But I did the multiplying by 5 first. Same thing. Alright, so hopefully, you got your tangent of a sum, tangent of a difference formulas down. You know what those are. I'd recommend memorizing them just to make things a little quicker for you. And hopefully watching me do one, like this helps you when you're working on these on your own. Thank you very much for watching.